G'day everyone and welcome back. Now, every now and again, I get requests to do videos on different topics, but none more so than one topic in particular. And while those requests started in the normal way, they certainly got a little more interesting as time went on. Attention shoppers, can the person in aisle 9 please hurry up and make a video on Backdraft? Thank you. Backdraft. So today, we're going to take a look at Backdraft. Now, the term Backdraft is unique in the world of fire science because it is one of the very few terms that is known by the general public. Now, this might be due to an action movie from the early 1990s that shared the same name, but Backdraft's notoriety, the fire behaviour, not the movie, is well deserved because Backdraft is one of the most dynamic and extreme examples of fire behaviour that can result from urban fires. Despite this, Backdraft is still entirely reliant on the fire triangle for its existence. Now, this means that Backdraft requires a specific combination of heat, fuel and oxygen before it can be triggered. And this also means that the fire triangle is actually an excellent tool for unpacking how Backdraft works. Now, when we're taking a look at Backdraft, in its initial stages, it actually has a lot of similarities with flashover. Because as we can see here, as a fire builds, the convection current will carry a lot of heat through the room. All this heat will then radiate down on all the flammable surfaces within that room. And as those flammable fuels within the room begin to heat up, they will eventually start to pyrolyse. And as they start to pyrolyse, they will give off more and more flammable gases until they reach a point where they will reach their auto-ignition temperature. Now, if there is a sufficient amount of heat, fuel and oxygen in that room will then go through flashover and continue to be fully involved. But if that room is well sealed, then the fire will run out of an essential element, and that is the available oxygen. Now, it's at this point where the difference between flashover and Backdraft becomes really clear. Because in flashover, there is more air being drawn into the room. But in Backdraft, that air has been used up. But captured within that room is still a lot of heat and an awful lot of fuel in the form of smoke. Because as we know, smoke can be extremely flammable. And that is really well demonstrated here because as we put the fire out, the smoke is then released. And we can easily reignite that smoke with a match. And you can see it burning back down the smoke column to reignite the candle. And this just demonstrates that smoke can be extremely flammable. Now, the interesting thing about pyrolysis is that it does not require oxygen to continue. This means that if there is a sufficient amount of heat and fuel in that room, then the pyrolysis gases can continue to build up. And this will eventually create a very fuel-rich atmosphere. Now, if we think back to the video on flammability ranges, we know that for every flammable gas, there is a range for which it is flammable. If there is not enough of the gas, then it is below its lower explosive limit and it won't be flammable. If there is simply too much of the gas and not enough oxygen, it is considered to be above its flammability range and it is also not flammable. It is only within those certain parameters where that gas will be flammable. The interesting thing is that in smoke we have a lot of different substances, which means we can see substances such as hydrogen, which is very flammable, carbon monoxide, which is very flammable, and formaldehyde, which is also very flammable. So we have a lot of very flammable gases that are contained within smoke. But that's not the only things that are contained within smoke, because we also have H2O, or water, which is not flammable, and carbon dioxide, which is also not flammable. So if we're talking about the flammability of smoke, it's really hard to estimate without actually measuring it. So for the purposes of demonstration in this video, we're going to come up with an imaginary flammability range for smoke, which looks a little bit like this. Now, it's important to note that this is entirely imaginary because the actual flammability of smoke can vary greatly depending on the combustion process, the availability of air, and the substances that are being burnt. But for the sake of demonstration, we're going to say that this is the flammability range for the smoke that is in this room. Now, as the fuels continue to pyrolyse, more and more of these flammable gases are going to build up. This means that we are going to be well above our upper explosive limit, and therefore it's going to be far too fuel rich to support combustion. Now, even after the fire has died down, these gases can continue to build up. And this is because pyrolysis does not need oxygen to occur. This means that the heat remaining from the fire will continue to pyrolyse the fuels and then completely fill the room with this potentially flammable smoke. Now, when we have a look at the fire triangle, we have lots of heat and lots of fuel, but nowhere near enough oxygen to support combustion. But if we open a door, then we can allow smoke to leave and air to be drawn in. As this cold air is drawn in, it can begin to mix with the fuel-rich smoke as it leaves the room. And as this oxygen-rich air and fuel-rich smoke mix with each other, they get closer and closer to forming a flammable mixture within the room. And in the case of backdraft, what can happen is this flammable mixture can find an ignition source. And if it finds an ignition source, this area of flammable smoke can then ignite. And when it ignites, it rapidly expands. And as it rapidly expands, it pushes the rest of the fuel-rich smoke out of the room. Now, as the smoke gets pushed out of the room, it may still be too fuel-rich to burn. But as it's pushed out, what it encounters is the oxygen waiting for it outside of the building. When this happens, the smoke that gets pushed out can then form a flammable mixture in the air, and then it can ignite. So now that we've got an understanding of the theory of backdraft, what we need to do now is go ahead and practically demonstrate it. But the question is how do we go about practically demonstrating something that is as dynamic and energetic as backdraft? And the answer is we need to go ahead and build a small wooden box. So as I said earlier, the initial stages of flashover and backdraft are really quite similar, where you can see the fire currently has plenty of heat, fuel and oxygen, and therefore it's going to be burning quite freely. But as it continues to burn, that smoke layer is going to continue to build up. And as that smoke layer builds up, it will begin to radiate more and more heat down on all of those fuels within the room. Now, as all of these fuels heat up, they will begin to pyrolyse and release more smoke into that room. As this process continues, we're going to be moving closer and closer to flashover. Now, with an ongoing supply of oxygen, then the fire can move through flashover to become fully involved. If we restrict the oxygen to this fire, then what will happen is the fire will die down, but all of the residual heat within the room can continue to pyrolyse those fuels, which will release more and more smoke into the room. And this will in turn then create a very fuel-rich atmosphere within that room. Now, the way to achieve that with this box is we allow the box to go through flashover, and then we're going to place a board over the doorway. And this will then force the fire to die down because we've removed its source of oxygen. So the fire will then die down, but all of those flammable smoke products can build up inside the room. This will then create a very fuel-rich atmosphere, and it will be well above its upper explosive limit. So when I remove the board from the door, what happens is the smoke can push out and air can be drawn in to create a flammable atmosphere. And then all it needs is an ignition source. And when it finds an ignition source, the smoke inside the room can ignite. And as it ignites, it rapidly expands and pushes out through the opening to the room. Okay, so now we've seen that backdrafts can come about from fires that are burning under heavily ventilation controlled conditions. Now this means that they have plenty of fuel in the form of flammable smoke, and they have an available ignition source within the room. What they need is that influx of air into the room so that a flammable mixture can be made within the room. That flammable area of smoke can then find an ignition source and ignite, and then the rest of that really fuel-rich smoke can be pushed out of the room. And that is an example of how backdraft can work. But that's it for this one. Thanks very much for watching, and I'll catch you in the next one. Cheers.